You know, what if the ground you walk on, the office you work in, or the bridge you drive over every day could actually talk to you? What would they even say? It sounds like something straight out of science fiction, but it's really not. Let's dive into this future where our cities are anything but silent. Yeah, see, that's not a line from a movie. It's the new reality that's taking shape in civil engineering right now. We're talking about a city that can literally sense, interpret, and communicate its own health. So, here is how we're going to break this down. First, we'll get into the big idea of a talking city. Then, we'll listen in on a real message from a building. After that, we'll explore the tech that makes it all possible, see where we humans fit into the picture, and finally, reimagine our entire relationship with the world we've built around us. All right, first up, what do we actually mean when we say a city can talk? Let's get into what this new kind of urban ecosystem really looks like. Okay, so the core idea here is to think of artificial intelligence as the city's central nervous system. It connects and integrates data from everything: buildings, bridges, highways, you name it. Every single piece of our environment becomes a node in this giant living network, constantly reporting its status. It essentially gives the city a pulse. Now, I know that might still sound a bit out there, so let's make it concrete. Let's listen to a real-world whisper and see what happens when a piece of the city actually decides to speak up. Picture this for a second. An engineer, let's call him Mohammed, gets this notification on his device. It's not some blaring alarm or a vague generic warning. Nope, it's a direct, super precise message from a building he's responsible for. The building itself is communicating a specific change in its condition. Wild, right? And look at that number, 1.8 millimeters. That's the incredible thing here, the sheer precision of it. The building isn't just saying, hey, I'm feeling a little off today. It's providing a specific, measurable data point that an expert can immediately understand and act on. For anyone in the field, this is a total game changer. It's this amazing convergence of several powerful technologies all coming together. You've got traditional structural engineering, the Internet of Things with its massive sensor networks, these things called digital twins, which we'll get to in a sec, and of course, the AI-driven diagnostics that make sense of it all. So how exactly does a huge chunk of concrete and steel find its voice? Let's peel back the layers and really look at the system that makes this incredible communication possible. It really boils down to a four-step process. First, you have sensors gathering all the data. Then, you feed that data into a virtual model. After that, you use AI to analyze everything. And finally, you present it all to a human expert who makes the final call. Let's break each of those down. Okay, so it all begins right here with what you can think of as the city's nerve endings. We're talking about thousands of tiny, embedded, smart sensors, things like fiber optics and little accelerometers that are constantly, 24/7, collecting data on everything from subtle vibrations and strains to tiny changes in temperature and moisture. They're the eyes and ears of our infrastructure. Next up, all that raw data flows into something called a digital twin. The easiest way to think about it is as a perfect virtual copy of a real bridge or a real building. But this isn't just some static 3D model. Oh no, it's a living simulation that mirrors everything about the real thing, its materials, the stress it's under, and it's being constantly updated in real time by those sensors. This lets engineers spot things like tiny cracks or metal fatigue in the virtual world long before they become a danger in the real one. Now this is where the intelligence really kicks in. Machine learning models get to work analyzing all the data pouring in from the digital twin. They're trained to understand what's normal for that specific structure, so they can instantly spot anything that's out of the ordinary, forecast how it might wear down over time, and even predict the probability of failure. It gives us these incredibly valuable early warnings. And here is maybe the most crucial point in this whole thing. The goal isn't to create a fully automated city that runs itself. The AI's job isn't to make the final call. Its job is to collect, analyze, and present information so that human experts can make better, faster, more informed decisions. The system augments our intelligence. It doesn't replace it. Which brings us right to the human element. Let's take a look at how this technology is fundamentally transforming the role of the engineers who build and maintain our entire world. Just look at this comparison. It says it all, right? The traditional role of a civil engineer was often reactive. You'd wait for a problem to show up, and then you go solve it. The new role? It's all about being proactive. They're becoming system managers, using this constant stream of data to get ahead of issues and manage the health of our infrastructure long before anything becomes critical. Remember that 1.8 millimeter message? Well, the system doesn't just send the number, it sends context. It shows how that number compares to the 7-day average, what the normal threshold is for the season, it classifies the risk, in this case low, and it even provides a recommended action. See, that's insight, not just raw data. It's the difference between a loud alarm bell and a trusted advisor. So, as you can imagine, the job description is changing. Engineers are now supervising entire fleets of assets, not just one bridge at a time. They're interpreting system-level behavior, optimizing maintenance schedules to save money and extend the life of our infrastructure. And they have to blend their deep engineering expertise with data science. It's a much bigger, more dynamic role. Okay, so for our final section, let's zoom back out. What does all of this actually mean for us, the people who live in these cities every day? Well, it signals a profound, new kind of relationship with our environment. I love this quote because it just captures the shift perfectly. Our infrastructure becomes an active participant in its own well-being. The city is no longer just a passive backdrop for our lives. It's an active partner in creating a safer, more efficient place to live. And that's really the ultimate takeaway here. This partnership, this collaboration between intelligent infrastructure and human expertise is what's going to enable a truly better urban future. It's technology making us safer and our world more resilient, all while keeping people, with our judgment, our experience, and our intuition, right at the very center of the decision-making process. And all of this leaves us with a pretty powerful question to think about. We've talked about structural health, but what about traffic flow, energy usage, air quality? What other secrets and incredible insights are just embedded in our urban environment, waiting for us to finally learn how to listen?